start Coulomb's law, I just give you one simple example where the forces of attraction, the force of attraction exists and the force of repulsion also exists. And let me start with a question here, that in a nucleus, atom has a nucleus, two protons will repel. Obviously it will be done by Coulomb's law. Then how do we ensure that two protons are there inside the nucleus? I mean, if they are experiencing repelling forces, how they exist in nucleus together? Electrons in orbit, they are also revolving, they also experience force of repulsion. But there is a definite reason in Bohr's theory. You will see that they need some extra energy to jump to the higher orbit. They leave the atom then only. We'll discuss everything one by one. Let us know just today's class the forces of interaction between two positive charges or between two negative charges or one positive, one negative charge. Positive charges are protons. Not only the region becomes electrically positive when some electrons leave the region, which I have explained in the last class. Protons really exist inside the nucleus. There is force of repulsion between them. There is force of attraction between positively charged nucleus and negatively charged electrons. How these forces will act and what is the magnitude of this force, that we are going to state in Coulomb's law. Coulomb's law in electrostatics, when you study, there are a few important terms here that I tell you what we are going to do. May not be completed in this class, but in the next session I will be coming with the topic which will not be completed here. The Coulomb's law and its discussion will definitely be there. Definition of Coulomb's law, its mathematical formulation and some simple theoretical and numerical examples. Then there is a term permittivity, that also we'll learn. May not be possible today's class, but definitely will come in the next class only with the concept of permittivity. Then vector form of Coulomb's law, the vector notation, its directional aspects. What is the application of vector form? And then finally it will lead to principle of superposition. We will solve lot many problems based on the principle of superposition today. Let us understand what is Coulomb's law. If we keep two charges in air, two positive charges in air or two negative charges in air, they repel. One positive, one negative, they attract. All these observation was done by Coulomb, and he describes the force between two charged objects. Initially, he stated the law this manner: force between two stationary point charges. Note the statement here. Force between two stationary point charges is directly proportional to product of their charges and inversely proportional to square of distance of separation between them. I am not stating direction right now. Imagine there are two charges Q1 and Q2 respectively in air. They are separated by, today's class all the discussion will be in terms of the medium air only. Charges are kept in air and what kind of force of interaction will be there, that we are going to discuss. According to Coulomb's law, these two charges will interact, maybe attraction, maybe repulsion, but that force of attraction F is directly proportional to Q1 multiplied by Q2. This is number 1. And number 2, F is inversely proportional to the square of distance of separation between them. This is actually inverse square law. What is that? Inverse square law you have studied in electricity. No, electricity you are doing now only. You have studied in gravitation. Inverse square law valid there also, that force of gravity is equal to g m1 m2 by r square. This is one of the fundamental force you have studied in class 11. It obeys inverse square law because F in that case was proportional to, is proportional to 1 by r square. It is always proportional to 1 by r square. In gravitation, we have seen inverse square law, and in statics also we are seeing inverse square law to discuss force of interaction between two charges. So if we combine these two, then F will be proportional to Q1 Q2 by R square. Okay. Now this proportionality we need to change into an equality. How to change this one into an equality? We need an integration constant, that K. Suppose you are taking K as, this is variation constant. Mind is preoccupied with the concept of integration, but all of you don't know. Before I explain anything with the help of integration, I should bring another session with application of integration in class 12 physics. I'll try my level best. So K is variation constant. This variation constant we apply here, and then F becomes K into Q1 multiplied by Q2 by R square. This K is variation constant. Its value in air is 9 into 10 to the power 9. You can see the unit. Past session I told you unit of charge, unit of force, unit of distance. So unit of K going to be Newton meter square per Coulomb square. Okay. In air, the value of K, this you definitely remember. In air, the value of K is this, 9 into 10 to the power 9 SI unit. So if I put the value of F over there, then Coulomb's law takes this form, which is given by F equal to 9 into 10 to the power 9 Q1 Q2 by R square. Experimentally, it was found the value of K, and this form is called scalar form of Coulomb's law. This scalar form of Coulomb's law will help you to calculate. That vector form, when you come to know, it will help you to determine the direction. Okay. So this force of interaction will be attractive. F is attractive if Q1 and Q2 are dissimilar, and this force going to be repulsive. F is repulsive if Q1 and Q2 are similar. Similar means they both are protons or both are electron. Dissimilar means one is proton, the other one electron, something like that. Okay. And I told you proton and electron perfect for discussing point object concept. And Coulomb's law is on this only, force of interaction between two stationary point charges. Very important statement. Is directly proportional to product of their charges, inversely proportional to square of distance of separation between them. Today's class, everything will be in terms of point charges. Then he'll say that, don't we solve problems where extended objects there? Definitely we will solve. When there are a group of charges, that will solve. And when there is an object, it may be line density of charge, it may be surface density of charge, volume density of charge, whatever. We'll be finding Coulomb's law application there also. Coulomb's law everywhere applicable. Okay? Even in nucleus, where there is very small distance of separation, Coulomb's law is applicable over there. Okay? I hope all of you have understood what is Coulomb's law. That in scalar form, it is 9 into 10 to the power 9 Q1 Q2 by R square. It gives force of interaction between two stationary charges in vacuum. I am telling vacuum only today. Dielectric constant or relative permittivity I will explain. I told you in another session, there I will explain bit different way using the concept of permittivity. But not today. Permittivity not today. Okay. Now let us see how much force is there between two 1 Coulomb charges kept separated by distance 1 meter in vacuum. Two charges 1 Coulomb each are placed 1 meter apart. The force between them would be what? That force by Coulomb's law, let us calculate. The force is F equal to 9 into 10 to the power 9 Q1 Q2 1 into 1 SI unit by R square. It means 1 square only. So this force is going to be 9 into 10 to the power 9 Newton. So between two 1 Coulomb charge, when they are separated by distance 1 meter, force is 9 into 10 to the power 9. This will help you to get the definition of 1 Coulomb charge. I told you before, the definition of 1 Coulomb charge we'll find here. Then what is going to be the definition of 1 Coulomb charge here? It is actually force of interaction between two, similar charges, and the force is 9 into 10 to the power 9. So it's write this manner. It is such a charge, 1 Coulomb is the charge which experiences nine into 10 to the power 9 Newton force when placed in air and separated by a distance 1 meter from a similar charge. Okay? And we are assuming that 1 Coulomb charge, we are assuming that 1 Coulomb charge is a point charge. Then only we apply here. You start thinking, 1 Coulomb charge, if a body acquires 1 Coulomb charge, what can be the dimension of the body? Okay, we have calculated for the definition purpose. We have defined, it is definition of 1 Coulomb we did today. But we might have violated the concept of point charge. I expect answer from you. You send me the answer writing in the comment box or writing it me separately. Have I violated concept of point charge here? Because Coulomb's law is on two stationary point charges. I am taking 1 Coulomb. An electron has charge 1.6 into 10 to the power minus 19 Coulomb. It is very small. So if an object has dimension very, very larger than that of electron or that of proton, then only it can acquire 1 Coulomb charge. But for definition purpose, we will carry this concept now, assuming this 1 Coulomb charge is a point charge object and the force of it exerts force of repulsion on similar charge 9 × 10⁹ Newton, or it experiences same force from the similar charge. Now let us do example 2 here. Two charges are placed 2 meters apart. Force between them is 0.5 Newton. One charge is given to be -1 Coulomb. What about the other charge? Let me explain. Two charges are placed 2 meters apart. So you keep two charges here 2 meters apart. These two charges, one is -1 microcoulomb, other one we don't know, but the distance of separation, that we assume Q, the distance of separation is 2 meters. Question is, if the force F equal to 0.5 Newton, what is the value of Q? By Coulomb's law, this force equal to 9 × 10⁹ Q1 Q2. That is 1 × 10⁻⁻6 into Q by R square. It means 2 square. So you cross multiply. 4 × 0.5, 2 equal to 9 × 10⁻³ Q. So Q is 2 by 9 10⁻³ Coulomb. 2 by 9 is how much? Approximately 0.23. I am writing 0.22 into 10⁻, or one can write this is 0.22 millicoulomb, because 1 millicoulomb is 10⁻³ Coulomb. All of you know this. So other charge is 0.22 millicoulomb. Now I am going to discuss another problem with you before we start its graphical representation. Charge -1 Coulomb placed at the origin. -1 Coulomb here, 1 microcoulomb here. Two charges, 2 microcoulomb each. This is 2 microcoulomb, 2 microcoulomb. This distance 1 meter. This is the origin, point A, point B. And this charge 2 microcoulomb. This is 1 microcoulomb. Distance is 1 meter. It's given. This one also 1 meter. Now question is, what is the force on the charge at origin? Charge at origin what? -1 microcoulomb. This is 2 microcoulomb. So what is happening there? This force -1 microcoulomb will experience force of repulsion. This manner. No attraction due to 2 microcoulomb. And due to this 2 microcoulomb, force of attraction. This force I am writing force experienced by charge at O due to charge at B. How to write this one? This is going to be F O A. Okay. So resultant force is the difference between these two. Let's see what is the resultant force. F O B. In what is the magnitude? By Coulomb's law, it is 9 × 10⁻⁹. I am considering the magnitude only. So it will be 2 × 10⁻⁻6 minus 1 × 10⁻⁻6. So let us calculate FOB. It is 9 × 10⁻⁹. Force of attraction between these two, 2 10⁻⁻6, 1 10⁻⁻6 by 1 square. This is in what direction? FOB. This is towards left. If you take this one positive x-axis, this one negative x-axis, then it is along negative x-axis. So along OB. This will act along OB. What about FOA. This one has magnitude 9 into 10 to the power 9, 2 into 10 to the power minus 6, 1 into 10 to the power minus 6 by 1 square. This is in what direction? Along OA. Now look at these two expressions, FOA and FOB, they are same. So how much force it will experience? Force experienced by it is going to be equal to 0. FO is equal to vector sum of AOA, FOB, this is going to be equal to 0. So these two are very simple, three problems I have discussed, very simple application of Coulomb's law. But we'll do more on it by knowing the vector form of Coulomb's law. Very important topic. Understanding of vector form will help you to excel in all kind of exam, not only for your board pattern examinations. It will help you to understand principle of superposition. We are going to discuss vector form of Coulomb's law. Okay? It will describe both magnitude of force and direction. It can be expressed in this form. This, if you can see that arrow is there. This R also, R cap arrow is there. We have to understand what is R cap. What is the direction of F? So let us take this three-dimensional coordinate system. Two charges situated at 2 points. One is at A, the other one at B. Position vector of this point A, this is taken as R1, and position vector of this is taken as R2. This is R1, this is R2. Now join these two. Join these two. Here there is charge Q1 and this is charge Q2. Okay? Q2 situated at the point whose position vector is R2. Q1 at a point whose position vector is R1. They are separated by this distance AB. AB is what? Y position vector concept. It is position vector of B minus position vector of A. This is nothing but R2 minus R1. Now let us write that force magnitude. If you write this force, we assume that they are of opposite nature. Let us assume that Q1, Q2 are of opposite nature. That Q1 into Q2, if I do one for you, you can do other cases yourselves. Q1 and Q2, Q1 into Q2 less than 0, that case I am going to discuss vector form of Coulomb's law. If it is greater than 0, you can discuss yourself. So this force, we are assuming that A experiences a force due to B, which is given by F12. F12 is what? Force experienced by the charge Q1 due to Q2, isn't it? Force experienced by charge Q1 due to Q2. F21, we are assuming force experienced by Q2 due to Q1. Okay, and they are experiencing attractive forces. We have assumed that the product is less than 0. Now if you write magnitude, if you write F is going to be Q1, no K, that K you must write. Vector form, no, that 9 into the power 9, we just write K, Q1, Q2 by R square, the attractive force. We are writing it for force experienced by Q1 due to Q2. What is the force? We have taken it as F12. F12 is what? K into Q1, Q2 by R square. What is R here? R is AB. AB is what? Mod of R2 minus R1. Okay? So F12 you got Q1 Q2 by R square, that force directed towards B. So should I write this one as R12 or R21? It is directed from this to this. Force experienced by Q1 due to Q2. R12 vector, we have taken what is the direction of R12. Let me tell you, R12 also. R12 vector joining A to B and directed also from A to B. Directed A to B. R21, this is going to be vector joining B to A and directed from where? Directed from B to A. Okay? You can take opposite manner, then everything going to be changed over there. Just everything means the direction part only. So this thing going to be what? F12, force experienced by it will be in this direction, that is along R12. Okay? R12, how to write? You better write this one along the direction AB. That will be better for you. You write AB cap. AB cap means unit vector. AB you have found, so you can write the concept of unit vector. And what is modulus of AB? Modulus of AB I told, R is mod AB. This mod AB is mod of R2 minus R1. So what is going to be now? Let us see that F12, if you write, it will be K Q1 Q2 by R square, this multiplied by R2 minus R1 cap. Okay? So this is K into R square. This you write R2 minus R1 vector divided by mod of R2 minus R1. So F12 going to be what? Mod of this thing is what? This I have written over there. Mod of R2 minus R1 is R, that you write, that you put here. It is going to be K Q1 into Q2 R2 minus R1, R square is already there, and R, it will be R cube. Okay? So F12 vector is going to be K into Q1 Q2 R2 minus R1 by R cube. This is F12. Force directed from 1 to 2. What about F21? Let us see. F21 will be what? If it is going from R2 to R1, I mean R2 minus R1, this is AB vector. This symbolically we can write R12. So F12 is what? F12 is K Q1 Q2 by R cube multiplied by R12. Vector joining from A to B. So this is for F12. What about F21? And this is vector form of Coulomb's law. F12 equal to this Q1 Q2, K Q1 Q2 by R cube into R12. This is called vector form of Coulomb's law. Similarly, we can write F21 equal to K into Q1 Q2 R21 by R cube. This is also vector form. And you can see very interesting thing over there, that R12 is what? This R12 we have taken AB vector. What is R21 vector? R21 vector is BA vector. So don't you think that they are equal and opposite? So this is minus AB. So therefore we can write this as equal to R21 I am changing minus K Q1 Q2 by R cube R12. This you take R12 cap, because this we have taken no cap, sorry, same thing. So minus K Q1 Q2 R12. So what you get? You get this vector form over there. So F21 going to be minus F12. This is vector form of Coulomb's law, and this is the significance. You need to know it. You need to know the important aspects of this one, F21 equal to minus F12. What are the concepts you have learned there then? That vector form of Coulomb's law, which is given by this one, and forces are equal and opposite. So let us note down some important points on vector form. What are those important points? Let us know. Those important points of Coulomb's law. What are those points? Importance of vector form. Number one. See, the formula we have derived, and we have shown that force is acting along the line segment joining these two. Vector form is possible if it acts along the line segment joining these two. As vector method completely explain the process, that representation of the Coulombic force in vector form, now we can say that the force of interaction F12 or F21, whatever you say, F21 or F12, they are central forces. What do you mean? Central forces means they will act along the line segment joining two charges. So they are central forces. Coulomb's law importance I am telling you. Number two, that forces are equal and opposite. So this supports Newton's third law again here. Electrostatic force of attraction between two point charges also obey Newton's third law, that forces are equal and opposite. Whatever force Q1 experienced due to Q2 is negative of force experienced by Q2 due to Q1. So these are two importance of vector form of Coulomb's law. Please keep this concept in your mind. And this one will lead to the concept which is known as superposition principle. What is superposition principle? Let me explain. You are considering presence of many charges. Many charges are there. Q1, Q2, Q3, Q4, Q5, Q6, many charges. I am not writing all. The force of interaction between, suppose this is the ith charge. This ith charge will experience force due to this Q1. It will experience force due to Q2. It will experience force due to Q3. But when you consider force between Qi and Q1, then you will assume that no other charges in their surrounding. Charges are there, but they cannot influence the force between Qi and Q1. Okay? So the force of interaction between two charges is completely independent of the presence of other charges in their surrounding. Okay? So Qi will experience force due to Q1. That force exists. So that force may be attractive, may be repulsive, whatever. This due to Q2 also it experiences force. Maybe attractive, maybe repulsive. Due to Q3 also it experiences force. That may be repulsive in nature instead of attractive. So then, how do you state the statement? How do you formulate here? That force of interaction between two stationary charges is independent of presence of other charges in their surrounding. Net force experienced by charge is the vector sum of all the forces. Suppose this force is F1, this force is F2, and this one is F3. Net force is vector sum of these three forces, or many, because force there due to this charge also may be repulsive, may be attractive. Here also another charge there, maybe it may be experiencing attractive force due to this or repulsive force, whatever. So net force experienced by Qi, this charge arbitrary one, that if we take Fi, this will be the vector sum of force due to charge 1, due to charge 2, force due to charge 3. It continues this manner. It cannot experience force due to itself. That Fii is not there. Fii minus 1 is there. Fii plus 1 is there. Okay. Finally, due to the nth charge. Okay. Fii cannot exist. It finally Fin. So this you can write. All these are vectors. Vector sum you have to find. So this is sigma Fij, j equal to 1 to n, and j not equal to I. This is very easy to understand, but application, many applications are there of this concept. This is the main concept here in Coulomb's law, that superposition principle. So I revise the concept once more. That force of interaction between two stationary charges not affected, better to say affected by the other charges in their surrounding. Net force experienced by charge is the vector sum of all the forces it experiences due to each individual charge. This is superposition principle. Let us apply the concept in solving one sum here. Okay? Read the sum here carefully. Three charges are placed at the vertices of an equilateral triangle with sides this. If the charges are 2 microcoulomb, 3 microcoulomb, minus 4 microcoulomb, what is the total force on each charge? So three charges are there. 2 microcoulomb, 3 microcoulomb, minus 4 microcoulomb. This is A, B, and this one is C. Three charges. I cannot do all the forces here. I will find it for one only, and then you find it for other charges. Let us do it. We are considering force on charge at E. Due to B and due to C, it will experience charge. They are placed in air. Nature of force you know, that formula of force also you know. So go step by step. This is superposition principle. When you consider force between 2 mu c and 3 mu c, we will ignore the presence of 4 mu c. Isn't it? So let us calculate this first. We ignore what? The presence of minus 4 mu c. So we are considering force experienced by charge A due to charge at B, that we are taking as FAB. Okay. So let us write FAB value. I am just writing the magnitude. FAB will be what? This is equal to Q1, Q2. This distance they have given 0.1 meter. Q1, Q2 means 9 into 10 to the power 9 always will be there. Constant of proportionality, 3 into 10 to the power minus 6, 2 into 10 to the power minus 6, so it will going to be 10 to the power minus 12. that divide by zero point 0.1 square. Just write the direction. It is a central force. It will act along the line segment joining two. This is along B to A. So if you simplify it, that if AB mod, you can write now. This is 654. 10 to the power, this will go up, 10 to the power minus 1. So this is 5.4 Newton. What about this thing? We are considering force on charge A. Let us write the vector form first. Force on charge A. Force on charge A. If you write vectorially, we are going to find FA, which is vector sum of FAB and F, this is A, no, and FAC. So let us draw the direction of FAC. FAC going to be directed like this. This is direction of FAC. What is the value of FAC? That FAC magnitude wise, it's going to be 9, 10 to the power 9, 2 into, we are considering magnitude only, not minus 4 means. So 2 into 10 to the power minus 6, 4 into 10 to the power minus 6, together minus 12 by this side length also 0.1 meter. So 0.1 square. So this is a 72. It is 7.2 Newton. An equilateral triangle. What is the length of side? Length of side given, that is 0.1 meter. And the angle is what here? That is this angle. This angle. I am talking about this angle. It is pi by 3. Means 60 degrees. So this is 120 degree. You find FA magnitude. FA magnitude will be what? You write FA square equal to FAB square FAB FAC into cos 120 degree. What you have to do there, you just substitute these values. 5.4 square, 7.2 square plus 2, 5.4, 7.2. Cos 120 minus half, you get the value of FA from there. Direction of FA you can find vectorially. That is again vectorially by parallelogram law or by using formula. This is the direction of FA. You need to find this angle. That use class 11, what you have learned, that tan theta equal to this FAB Q sin theta. I mean FAB sin 120. Okay, Q sin theta by P plus Q. That is F AB F, I just tell you this thing. If this is vector P, this is Q and this is the resultant. This total angle is theta and this is alpha. Tan theta is Q sin theta. Sorry, tan theta no, it will be tan alpha. Tan alpha, this angle you found by this formula. Tan alpha equal to Q sin theta by P plus Q cos theta. By using this formula you can get the direction. Okay. So fundamental concept you got here. I will not say fundamental concept. Electrostatic. Okay, fundamental, but Coulomb's law we are discussing today, and it explains the nature of fundamental force, that is electromagnetism. Right now for electricity, later on magnetism, and Maxwell combined these two. He stated laws of electromagnetism. Okay, I hope all of you have understood the theory part of Coulomb's law. Now let us do these few sums very fast. We'll do one by one without wasting time. Let us solve these few sums. The question given here, find the ratio of electric and gravitational forces between a proton and an electron. How to find the force that between electron and a proton? They have the same amount of charges. That force going to be 9 into 10 to the power 9. You have to find the ratio F electric by F gravitation. We want to find this ratio. Let us write the value of Fe first. What is the value of Fe? 9 into 10 to the power 9. Q1, Q2. Q1 electric, electron and proton, same charge. Q1, Q2 by R square. Suppose they are separated by distance R here. This part is R. Simplify at the end. This force is electric. Gravity force between them you consider Fg equal to G m1 m2 6.67 10 to the power minus 11 G m1 m2 mass of electron, mass of proton by R square. You need to put the value of mass of electron and mass of proton. Mass of electron is 9.1 10 to the power minus 31. So it will help you to get Fg. So 6.67 10 to the power minus 11, 9.1 10 to the power minus 31, and then 1.67 10 to the power minus 27. Heavier than electron, mass is large, that divided by R square. Okay. So you got Fe. They asked you to compare electric and gravitational force. You got Fg. Now let us find Fe by Fg. What you will get if you calculate Fe by Fg. I have calculated this, that Fe by Fg, not showing calculator here. So Fe by Fg, approximately it's coming to be 2.26 10 to the power 39. So one very interesting thing we have observed, that Fe is approx 2.26 into 10 to the power 39 multiplied by Fg. Gravity is really a weak force. Electric force is not strong force. Strong force is another category. So electric force is 10 to the power 39 times, order of 10 to the power 39 times larger than that of force of gravity. Very large. At home you compare the force of repulsion between, and this force is attractive because electron proton there. Home you calculate electric force between two protons. Now one question I am going to discuss with you, where the graphical concept, graphical representation is involved. How do I apply the concept here? Let me explain one by one. Okay. Plot the graph showing variation of Coulomb force versus 1 by R square. Let me plot the graph. F, you know, 9, Q1, Q2 by R square. Okay. with r square, they have asked you to find f versus 1 by r square. So if you take 1 by r square is a constant, this is also a constant. So f going to be equal to some another constant m into their product. This product is variable. This is a variable, but m equal to what? That variation constant. No, not variation constant. That constant I have taken as m. This is fixed. So f equal to m into q1 multiplied by q2. That m is this thing. We are going to plot the graph of f versus, wait a minute, variation of Coulomb. Oh, sorry. We are going to consider not that one constant. q1, q2 is a constant. Sorry. q1 into q2 is a constant. 1 by r square is a variable here. So you take 1 by r square this way, f this way. Okay. So q1, q2, if this is positive, f is going to be a positive quantity, 1 by r square, a positive quantity into a positive quantity, 9, 10 to the power 9, q1, q2. So f versus 1 by r square, 1 by r square, if you plot, it is going to be a straight line, because 1 by r square you take as x here and f as y. So this y going to be mx type of graph, m into x. M into x graph is a straight line. For positive value, it will pass through origin. For negative value, it will also pass through origin, but directed this manner. So this y, because q1, q2 is less than 0. Here, q1 into q2 is greater than 0. So graph will be like this. Okay. But in general, when you consider graph of Coulomb's law, that f is proportional to r, I mean f versus r, we have plotted f versus 1 by r square, that's why we got a straight line. But f versus r, if we try to plot, it is going to be f equal to a constant L by r square, this type of graph. So what is f versus r graph for Coulomb's law? The graph going to be like this. This is r, this is f. It falls rapidly. R square is there. So the graph going to be like this. Okay? As it obeys inverse corollary in case of gravitation, you have seen that here also. So with distance, it falls. How does it fall? Suppose distance r becomes r by 2. Then force F becomes F dashed. Then see, F into r square equal to F into r square equal to constant. It is F dashed into r by 2 square. So F dashed becomes 4 times F if the distance between them is halved. Okay? But we are discussing problems on Coulomb's law now. Let us find this one. That a charged particle of mass m, you can see the problem here. Charged particle, this is Q1. Sorry, this is Q1. Charged particle of mass m and charge minus Q1. It has charge minus Q1. Start moving around a fixed positive charge Q2 in a circular path. Minus Q1 here, just like proton and electron. This is like electron and this is proton. You have to find time period of revolution. You will say that due to electric force, due to electrostatic force, it collapses. I mean, minus Q1 will go to Q2. No, it is not true. Because in circular path, it will experience centrifugal force first. As soon as you are taking a body in circular path, centrifugal force comes into effect. That centrifugal force will be opposed by electrostatic force, and this compels charge minus q1 to move in the circular path. So here we'll write Fc equal to Fe, centripetal force provided by electrostatic force. What is centripetal force? This one, suppose this one has mass m. I forgot to put the mass m here. Okay. No, it's mass given m, mass given. So Fc is what? Orbital velocity be v, radius be r, mv square by r equal to q1 into q2 by r square. This k part is there, k will replace earlier, afterwards. Your problem is to find time period. R getting cancelled. Now v equal to what? 2 pi r by t. Substitute there. So m into 2 pi r by t whole square equal to k into q1 q2 by r. You need to find t. So t square is 4 pi square m r cube by k q1 q2, 9 to the power 9 into q1 into q2. So time period can be determined. Time period going to be what? Under root this thing. 9 10 to the power 9